This is worksheet 3 of the atomic structure packet, and this is going to be part 1 of a 2-part series on this worksheet. So, this worksheet is all about learning how to write electron configurations, which is our second sort of diagram that we're going to write to represent atoms, simply by looking at an element on the periodic table. And you're going to need to remember what we talked about in worksheet 2 about how we can locate electrons in orbitals. So a 1s orbital, or a 2s orbital, or a 2p orbital, and so on and so forth. Okay, so I want you to take a look at an electron configuration that I have written for oxygen. Okay, this electron configuration is telling us that in the first energy level, that's that one is there, so the first shell around the nucleus, and specifically within that shell, within the s orbital, there are, I don't know if I can circle this, whoops, I kind of missed it, there are 2 electrons. And in the second energy level, so there's a 2 there and a 2 there, there's both an s orbital and a p orbital. And in that second energy level's s orbital, there are 2 electrons. And in that second energy level's p orbital, there are a total of 4 electrons. Now, you might be thinking to yourself, wait a minute, in the last worksheet, you told us that each orbital could only hold a maximum of 2 electrons. Well, that's true. But remember that the p orbitals can kind of get grouped together. So if you have 2 electrons in a px orbital and an electron in a py orbital and another electron in a pz orbital, then that's a total of 4 electrons in the 2p orbitals. All right, so it's because we're grouping the px and the py and the pz all together that we can have a total of 4. Okay? All right. So it's not telling you in an electron configuration anything about protons or anything about neutrons, but it's telling you in a really specific way where all of the electrons are. And if you add up all these little numbers that I've sort of tried to circle here, which we call superscripts, right? You have a 2 and another 2 and a 4. Well, you add those together, 4, 5, 6, 7, 8, and that's the number of electrons that oxygen has. Oxygen's atomic number, so its number of protons, and therefore its number of electrons is 8. Okay, so that's where all the electrons that oxygen has can be located in a much more specific way than a Bohr diagram could tell us. Okay, now if we look at sulfur, I want you to notice some patterns. Okay, sulfur has in its first energy level an s orbital with 2 electrons in it. In its second energy level, it has an s orbital and a p orbital. The s orbital has 2 electrons. The p orbital has 6, so that means its px orbital has 2, its py orbital has 2, and its pz orbital has 2. They all are filled. That's how we get that total of 6, because we clump all those variations of the p orbital together. Okay, now, unlike oxygen, sulfur has a third energy level, a third ring around its nucleus. And in that third energy level, there's an s orbital that has 2 electrons in it, and there's a p orbital that has 4 electrons in it. Okay? Now, if you add those all up, 4 plus 6 is 10, 11, 12, 13, 14, 15, 16. If you add all those little numbers, little superscripts on sulfur up, you get 16. Well, sure enough, that's the number of electrons, the atomic number of sulfur. So that's where all of sulfur's electrons are located, around its nucleus. Okay? Now, hopefully your paper's not quite as marked up as mine and you can actually see, but if you compare oxygen and sulfur, I want you to notice that the very end of their electron configurations have something in common. Okay? Oxygen's only goes out to 2. It only has 2 rings around its nucleus. Sulfur's goes out to 3, so that's something different. But both of them end in an s orbital with 2 electrons in it and a p orbital with 4 electrons in it. Okay, now this is actually important. This is something that you, hopefully by the end of this video, will be able to notice without actually seeing the full electron configuration of oxygen and sulfur, like I have written out here, but just by looking at where they are on the periodic table. Okay, so I want you to take a look at this periodic table. All right, we're going to divide the periodic table into 3 blocks, 3 sections. Okay, I've written in on this periodic table just where oxygen and sulfur are, because none of the other elements are written in. I wanted to orient you to where oxygen and sulfur are. Okay, oxygen and sulfur are both in a section of the periodic table that we call the P block. So I want you to label this. See how I've circled it in green? Okay, so all that's in green is the P block. All right, and what that means is that all the elements in this whole green area, their electron configurations are going to end in a P. Okay, now, since sulfur is in the 3rd row, that's what this is saying, right? So this would be the 1st row, 2nd row, 3rd row. Because it's in the 3rd row of the periodic table, it's going to actually end in a 3P orbital. If you look back at its electron configuration, it did. Okay, now oxygen is also in the P block, but it's in the 2nd row of the periodic table. Right, rows are the horizontal ones. So it's going to end not in a 3p, but in a 2p electron orbital. All right. Now, there's not just the P block on the periodic table. Okay, in the over on the left side here is the S block. So any element that falls within this red rectangle here is going to end not in a p orbital, but in an s orbital. Okay, and helium, here's helium over here. It's actually, sometimes you even actually see helium drawn in like over here on periodic tables, because in some ways it could kind of fit there in terms of patterns. Helium actually ends in an s orbital, so that's the one little sort of outlier here. Okay, and then this middle section of our periodic table, this is called the D block. So these end in d orbitals. Okay, now one thing to know about the D block is that it's sort of like behind by 1. So even though this whole row here should really be the 1, 2, 3, 4th row of the periodic table, these all end in 3D. So they're just one behind instead of ending in 4D like you'd think. And this whole row is 4D. And this whole row is 5D, and so on and so forth, although I wouldn't have you write the electron configuration for something way down in that 5D row. All right. So we can use this information to help us write an electron configuration of an element. Okay, so let's try to write the electron configuration of oxygen without looking at it written up at the top of our paper. Okay, we'll see how we do at the end. So for oxygen, I'm going to just write its little symbol that it's got a mass of 8, an atomic number of, a mass of 16, an atomic number of 8. All right, oxygen, just to kind of remind me that's what I'm writing here. Okay, and here's what I'm going to do. This is like a board game. Every time I start to write an electron configuration, I can't start way over here where oxygen is. What I'm going to do is every time I'm going to start way over here with the very first element. The element with atomic number 1, which you may remember is hydrogen. Okay, and I'm going to move in order of atomic number from hydrogen to helium to lithium and beryllium, and over here to boron, and all the way up, and I'm going to go until I get to oxygen, because that's the element that I'm trying to write the electron configuration for. Okay, so if I start here at hydrogen, I see that hydrogen is in the S block, and it's in the first row. So I'm going to write first row, S block. Okay, and now I'm going to look and see if hydrogen is the only element that's in the first row in the S block, or if there's another one. Well, turns out over here, helium is also in the first row, and because there's a kind of funny rule, it's also in the S block. So that means I have a total of 2 elements that are in the first row, S block. So I'm going to put a 2 up here. Okay, so that was my first element. My second element, I go to where my third element is. If it was labeled, it'd say lithium. It has an atomic number of 3. And I see that lithium is now in the second row, right? But it's still in that S block. It's still in that red circle. Excuse me, red rectangle. Okay? So it turns out that lithium and also this element here, which would be beryllium, are both in the second row in the S block. So I'm going to put a 2 here. Okay, so that was my third and my fourth element, and now over here, this is my fourth element. It's got, if the periodic table was all filled in, it'd say boron, a B, and it'd have an atomic number of 4. All right, now boron here is still in the second row, but it's not in the S block anymore. It's now in the P block. So I'm going to write a P. And I'm going to look and see how many other elements are in that 2p section of the periodic table. Well, boron is, and then this element would be, and this element would be, and oxygen itself is. Okay, now I know that this element here and this element here are also in the second row in the P block, but I stop once I get to the element that I'm writing the configuration for. So that means I've got 1, 2, 3, 4 elements counting through to oxygen, which is what I'm writing my electron configuration for. Okay? All right, we'll do one more. Let's try sulfur. Okay, so here's sulfur down here. All right, so sulfur, which has, what did we say, 16. And I could flip real quickly and see what its mass is. I don't have that one memorized. Sulfur has a mass of 32. Okay, so I'm going to always start way over here. Now, this is messy now, but I got to start way over here at hydrogen. Okay, and remember, both hydrogen and helium are in the first row, and they're in that S block. So there's 2 elements in the first row S block. Then my third and my fourth elements, lithium and beryllium, are now in the second row S block. And if I go to my 5th, 6th, 7th, 8th, 9th, 10th, right, this time I'm not stopping at oxygen, because I'm writing the electron configuration of sulfur this time. That means I've got 1, 2, 3, 4, 5, 6 elements that are in that 2p section of the periodic table. Okay, now I go down here. So I'm going in order of atomic number, and if you look at your periodic table, you'll see the atomic numbers on there. Okay, so this is my next element here. Well, this is now in the third row, S block, and there's 2. This one and this one are both in the third row S block. Next I move over here, I've got 1, 2, 3, 4 elements that are in the third row, P block, until I get to sulfur. And then once I count through sulfur, I stop. Okay? So this is something that takes some practice. You might not feel totally confident about it now, but we will practice this the next time that you get to class.